Hey everybody, it's Matt from Eastwood Company. Thanks for joining us for another live tech demo. Kevin's been covering a lot of coatings and painting recently for you guys to learn a lot about that. We're going to come back and do some welding here today in the Eastwood studios. We recently did a TIG welding, intro to TIG welding class online where we taught you just the basics on how to strike an arc, what happens inside a TIG welder, and everything like that, some best practices. And afterwards, we got a ton of questions about people wanting to learn some more intermediate type things in aluminum and sheet metal for steel. So we figured we'd do another follow-up class where I'm going to give you some tips and tricks on doing sheet metal. We'll get into some aluminum, and we'll give you some common things that people were doing wrong that may cause issues. Hopefully correcting those will jumpstart you into laying some sweet dimes on the metal. So the first thing we're going to cover is just cleaning the metal. It's real rudimentary, but I think it's very, very important. TIG welding, I can't stress it enough, needs to be as clean as possible. Think of it like an operation table. It needs to be as clean as you can possibly make it for the best looking welds. So there's a few different ways you can clean the metal depending on what you're deciding to do, what type of metal you're working with, how it was cut. There's a bunch of different ways, but I'll go through these real quick. The first one, and probably the most aggressive, is using a flap disc, like an 80 grit or 60 grit flap disc on an angle grinder. I actually prefer to use ones that are already kind of worn if all I'm doing is just cleaning off some surface corrosion on the metal. But if you have something that, say, you cut with a plasma cutter, there might be some slag on it, or even if you were using an oxyacetylene torch, there's going to be some slag, some leftover junk on there. Using this is going to cut right through it, it's going to knock it off, it's going to get it down to bare, fresh metal. That's the best first area to attack it with. First thing to attack it with is the angle grinder. So if you have something that's not nearly as bad, say it's just something you got, like we have pieces here. This is just clean aluminum that we got right from the mill. This is what it's going to look like. It has like a protective coating that they put on it so it doesn't start corroding while it's sitting there on the rack. And what I did was this piece here actually used one of our DA sanders. So if you get one of these palm sanders like we sell, we have a little palm DA sander. These are really handy. What you do is you throw a piece of 80 grit sandpaper on there and just go over the piece. Aluminum, steel, whatever, anything that's fairly clean already. If you use this, it's going to take off any light corrosion on the metal, or it's going to take off that light coating that they put on a lot of different metals just to keep them from corroding while they're sitting on the shelf. So this is kind of what I use 90% of the time. The other reason that this is good if you're doing like sheet metal repairs, like on 20 gauge or 18 gauge, anything like that, that's already pretty thin. So if you go and use a flap disc, this takes away a lot of material really fast. So if you're not careful, you'll have this 20 gauge sheet metal, the thickness is going to be cut in half in an instant, especially right where the weld joint is, which is going to make it difficult to weld. It's also going to make it weak, so you don't want that to happen. So if you use the DA sander, it's a little easier to control. You can just take off just enough to make it clean metal and go from there. So the next thing that you can use, so if you have a piece that's pretty clean and say it's sat, for the afternoon, and you come back and you're ready to weld, I would keep a set of these stainless wire brushes on hand. These are good because you can just take off any light corrosion, fingerprints, minimal grease, anything like that. It'll take it off with this. One thing to mention that we see people do is you do not want to mix these with your normal wire brushes that you're using to clean your engine or clean under the hood, because they're going to have grease and grime on them, and when you put it into the metal, you're putting that grease and grime into the metal, and like we said, you want it to be as clean as possible, so that's a no-no. So get a set of these, and I like to mark them and write on them steel and aluminum. That way that you're not using one that's for aluminum on steel and you're getting rust and corrosion from the steel on the aluminum. That's going to cause some issues and could be a mysterious kind of dirt that's going into your metal, even though you think you cleaned it really well. It could be just cross-contaminating with the brushes. So get a set of these, write on them if you can, and keep them separated. That's the best practice. The last thing that I do, and I use probably the DA and then these as probably the most common thing that I do when I'm prepping metal, is these Scotch-Brite pads or surfacing pads. We sell these in little packs you can get. There's different grits. There's gray, there's red. There's a few different ones. Any of them will really work. What you want to do with these is you're gonna hit the area right around where you're welding to make sure that it's just that one last swipe to make sure it's clean. So I got a piece of sheet metal we're going to show you how to weld sheet metal on as if we were doing a patch panel. You can see up here on the top where it's shiny. That's where I actually cleaned it with the pad. And then down here below is where I didn't. Even though the metal looks pretty clean, it's got tons of fingerprints on it. It's got a little bit of grease or film on it that's just from sitting around the shop. You got to get that off. That's going to go right into your weld when you're welding. So before we actually start on this piece, I'm going to probably hit it with this just on this other side, make sure it's really clean. The last thing you can do, and it's more important when you're doing aluminum, is you want to get some acetone on a rag if you can, and wipe the piece down after you've handled it. If you can, without touching it, wipe it down with some acetone if you really, really want to be as clean as possible. That's really a best practice. Even on steel, it's good just to get any last fingerprints off. If you can get yourself to start doing that, you're going to really start doing some clean work. I know it is difficult to keep that at your workbench and remember to do that, but if you can, especially when it matters on a piece that really needs to be a clean piece, make sure you do that. So we're going to jump right into sheet metal, and I'll show you a little bit of some tips and tricks with that, show you laying a bead with the sheet metal, and we can go from there. The torch I'm going to be using today, I'm using, of course, our TIG 200 AC/DC because we're doing aluminum and we're going to be doing some steel today. So this kind of does both with just a couple flicks of the switch. The torch I'm using today is one that we offer separately. It's our what we call a mini torch, but for anybody out there that knows the torch names or sizes, this is what's called a WP9. So this torch is good up to like 100 amps, 110, maybe 120 amps. It's good up to. So we're doing fairly thin stuff today, so I can get away with this torch. If you're doing some longer runs on aluminum especially, or thicker steel, this torch is probably going to be a little too small, and you may have some issues with it starting to get a little hot because this is just an air-cooled torch. It's not water-cooled, so you may have to upgrade to the larger WP17. Now, the other thing I have on here, if any of you have this TIG 200, you may know that they come with a gas cup that's like this. You may notice that I have a larger one on there. What I have on here is a gas lens. These are really good to have if you want to get the basic concept of welding down. Upgrading these gas lenses is a really good thing, especially with aluminum. It's I almost want to say necessary to help with getting clean welds. These gas lenses are a little different. Instead of just having some holes drilled in the collet like these, or in the collet body, like this style would have threaded into here. This actually has a mesh screen, which is really difficult to show on camera, but it's basically like a wire mesh that's on the inside. When you put the shielding gas out, it kind of gives it a fogging effect rather than shooting it straight down. What that does is it encompasses the whole weld area and it shields it from any contaminants much better than with this. So you can use less gas. You can have your electrode or your tungsten sticking out further because it's it's fogging around more. So if you're getting in tight areas, this is good. And it's just it keeps everything cleaner all around. So I really do like these. If you can upgrade to these once you get going, that's a good upgrade to buy. It's worth its weight in gold. We're going to be offering probably in about the first quarter of next year. We're going to have this kit for our normal WP17 torch that comes with the TIG welder. We're going to have a real affordable gas lens starter kit that we're coming out with. This is one of the first ones we have here. So this will give you basically everything you need to convert your torch to a gas lens and get you welding a little bit cleaner. So that's all the products and all that stuff. So let's get into some welding, probably while you guys are watching. So like we said, I have some sheet metal here that we're going to be using. This here I believe is 18 gauge that we have. And as I mentioned, you're going to want to clean both sides. So I'm just going to go over this, re-welded. And I have a piece here that I kind of made that's like a patch panel, if you could imagine. I wanted to do something longer to show you basically the process in a smaller form. What you would do when you're TIG welding sheet metal. So you want to try and get into the groove there. Now this piece is already one piece because to save time, I clamped this down on the table, and I just did a handful of little fusion welds. So a fusion weld is when you have the two pieces of metal really tight, they're right next to each other and they're really tightly pushed together. So when you hit that arc, it makes a tiny little puddle and melts the two of them together. So you do these little fusion welds, and that can get you kind of set so your panel's at least got it's going the right way for you. And then from there you can start welding. Now if you have a really, really good fit up on your panel, you could potentially just fusion weld this whole entire thing together. You are going to have a little divot there because as you're melting it, it may dip down into it. So it's not a bad idea to add a little bit of filler rod, fill it up, get full penetration on the front and the back side. So that's what these little tiny dots here are. They're the little fusion welds I did just to get it as one piece. The other thing to mention with if you're going to start getting into using a TIG welder when you're doing patch panels or sheet metal work, fit up is very important. It's just as important as having clean metal. If you don't have a nice fit up and the joint, the two pieces of metal don't fit together well, you're going to put more heat into the panel. You're going to be filling holes. It's going to cause a bigger issue. So you don't want to do that. Spend that extra half an hour, 45 minutes, whatever it takes, with the belt sander, with a file, with sandpaper, getting it just as close as you can get so that there's little to no gap. So this piece I just cut in half and put it back together to make my life easier. So of course the fit up's pretty much perfect. When you're cutting like say a quarter panel out of a car, putting a new piece in, it might be a little more difficult. But again, if you spend that time just getting it as close as possible, it's gonna result in less time grinding, less heat into the panel, less hammer and dolly work to get it straight. All around less filler, which is obviously what we're going for here. So that's all your warnings, all the boring stuff. So we'll get into doing some welding here on the sheet metal. And I'll show you a couple things as we're going along. I'll show you what happens when you're actually welding the sheet metal and how you can basically correct it. Now, one thing that's nice about TIG welding sheet metal versus MIG welding, I know we get it a lot of times when we do videos on patch panels with a TIG welder and things like that. Guys say, oh, I could do that with a MIG. You can do that, but MIG welding, no matter how good you are at MIG welding, you're going to have to do grinding to grind that weld down. A MIG weld, just by nature, is a harder weld. It's going to sit above the surface. No matter how good you are at getting the welder set up perfect, you're going to have this bead that sits on top of the surface because it's not as easy as with a TIG welder where you can add just enough filler rod, just enough that it needs to keep it as flat as possible. Whereas a MIG, you get what you get, and it's kind of hard, so you have to grind some of the weld down, and that's putting more heat into the panel. So you want to grind as little as possible. And the other thing is that you can keep your heat effective zone pretty small with TIG welding. So once you get pretty good at it, you can do little short blasts, and you get more area welded with less heat put into the panel. And probably the other final reason it's really good is it's close to oxyacetylene welding in that you can hammer the weld. You can actually hammer on the weld, it can flatten it out. So some guys like to do it when immediately after they weld it. Some guys will do it all the way at the end. No matter what type of welding you're doing when you're doing patch panels, and I can't stress this enough, you're going to get warpage. It doesn't matter. It's just the nature of the beast. When you put heat into a panel, it's going to shrink. When you're welding, it's going to shrink around the weld, and you're going to have to correct that. So no matter what type of welding, you're going to get that issue. It's just learning how to correct it. So the one way to correct it without using a lot of filler is you can learn how to hammer and dolly the weld and stretch the area that's shrunken down in the actual weld seam. You can hammer on dolly on it, and it'll actually stretch the weld back out. It'll relieve the tension that's in the panel and kind of get it back to its original shape. So as we're doing this, you'll probably see what I'm talking about, and I can kind of show you what you're going to want to do with hammering on dolly. So let me get the welder set up. So of course, got the TIG 200 like I said. Our gas is turned on. We're on DC here, and I'm going to adjust the amperage on the foot pedal. When you're welding sheet metal, you're going to keep it low amperage. You're going to be in the, max you want to set your pedal for, depending on the type of welder you have, but you may max 80 amps, and you can work in that range from 0 to 80. You're probably going to be more in the 50 amp area or somewhere in there, depending how you like the weld. Maybe a little less, maybe a little more. But the idea with doing sheet metal, if possible, is to work Get in hot, work quick, and get out. That way you can get the heat in, get what you need done, and get out. If you sit there and spend more time welding, you're putting more heat into a panel. So if you had two people next to each other and one guy that welded really fast and hot and a guy that welded slow and not as hot, the slow panel is going to have a lot more warpage to it because he's putting just a longer time of heat getting put in the panel. So that's one of those things that takes a lot of practice to get like that, to get to that point, but it's good to get there if you can. So I got my torch here. Again, you're going to want to use a 1/16 electrode of tungsten in here. I have a 3/32 in here because we're doing some aluminum welding, and with the 1/16 it wants to, with the 1/8" aluminum plate, it wants to start kind of wearing away the tip of the electrode. So to make it easy so you're not sitting there watching me unscrew this, I'm going to leave this electrode in here. So you can do sheet metal with this if you're careful. You just want to make sure, especially when you're doing sheet metal welding, that you sand or grind your tungsten to a fine point, pencil point. That's going to keep it, your arc, directed as like a pinpoint arc, which is what you want. You only want to be welding on just the area, just the seam. So let me get this, make sure we're set here. So like I said, I have the pedal set here, right around 80. I'm not going to be using all of that 80. I'm going to be probably much on the lower side, but I set it there just in case. Just in case I got to goose the pedal a little bit to get the arc started or go a little faster. You have that range there. So that's all a personal preference where you want to set the pedal, but you're not going to be using any more than that, I can tell you that. So we're going to start over here. It may take a few seconds for the camera to focus. He's got to flip down a welding lens so you guys can actually see what's happening. The weld is going to be really small, so it may be a little difficult to see. So you know what, I'm going to actually start probably here to make it easier for you guys to see. I'm going to do right in here, and then we'll jump and go across. So I'm going to do a little short blast. And then we'll go from there, and we'll talk a little bit afterwards. So we're going to do 2 or 3 in a row and jump and show you what you do and show you what happens. All right, you ready, Joe? All right. So I'm barely on the pedal here. Oh, see, I didn't have good fitment there. See right there what happened, and this is live, that's what happens. See how the panel's overlapped a little bit? That was my mistake. I didn't have the panel dead flat there. What happened is it wanted to open up a hole on me. So I just had to put an extra dab of filler in there to cause that issue. So you don't want that to happen. That's exactly what I was talking about, and that's my fault for the panel not being flat there. So we'll move down a little bit. I am using a thicker rod. This is a 1/16. I really like to use 030. If you can get 030 in a bundle, it helps quite a bit. But it's a little more difficult to get. I'm just using the 1/16 to show you guys because this is what's readily available. So let me try and do this one here a little easier. And actually, I'm going to turn this pedal down a little bit so we're not nearly as... So you just want to do quick, short little bursts like that. And you could probably even see that metal moving on its own. That's from that heat kind of shrinking it together. And that's what happens. You know, it's moving, it's twisting because of the heat that you put into it. So you're going to want to jump around, just like if you're doing MIG welding, you're going to jump around. I know it's hard to see. I can't weld for a real long time or it's going to start warping the heck out of this panel. So I'll do one more here. And the arc is really small. It's difficult to do those, the stack of dime look that you want because you're just going to be in and out. Some guys can do it. I'm not really there. The main point is that you're trying to get it fused together. So, all right, Joe, you ready? So doing quick little welds like that. You can go a little further than that if you want, but you may start getting a little too hot depending how quick you are at it. I like to do short little bursts. Now, the thing to show here is the back side of the panel. So, I don't know if you guys can see there on the back side. You're getting full penetration there on the panel. That's very important. So the filler rod's going all the way through, or your weld's going all the way through when you're adding filler rod. That means you got a complete fusion together. So when you sand this down, it's going to be all one. You can blend it in. Now I don't know if you guys can see. Well, here you can probably see a little better. Let me know if I need to tilt it. If you could see how it's bowed in the center. Let me know if I need to go up or down or tilt it. Is that good? So there you can see that there's that bow in it from welding the panel. So what you can do then, you can either do it in between or you can wait all till the end. For me, and probably because I'm not as experienced as some, a lot of other people out there. I'm really a beginner myself. I like to, between every few welds or every weld, depending what it is, I'm going to hammer that weld. So let's see if we can. So imagine this was a panel, you're holding your dolly behind, and you're going to want to hit right on the weld there. You're going to want to hit right on the weld there like this. So what you're doing is you're stretching that weld area back out. And also, and I'll show you after I do these couple hammers, TIG welding is a lot softer, so you can actually flatten the weld out. You can planish the weld, so it requires less grinding. Here to this final one. So that got us a little better. I don't know if you could see there, but not nearly as crazy of a V to the panel or a valley there. You can see it's a little better. I'm going to flip this around then because you can really see on the other side it kind of flattened out. Let me flip this and I'll do the same thing like that or the other way. Like this. There we go. So you could really see, especially where that weld is, it flattened out quite a bit just from that little bit of hammer and dolly work. You don't need to do a lot, but you need to do a little bit, a little hammer and dolly work just to flatten it out. And let's see if I can show you on one of these. So this one right here, you can kind of see you can see how the weld actually kind of flattened out. It got smashed down. So that's planishing the weld out. It's actually flattening it out. It's going to require less grinding because you're getting the weld planished out, smoothed out by doing that. So it's going to be difficult to get a smooth, something like that requires almost no grinding with MIG welding. It's possible, but it's not very easy. Neither is this, but this is another method for welding sheet metal. So that's the sheet metal. This would still, if you weld this, you're going to have to keep going back and forth, doing hammer and dolly work as you go. It's just the nature of the beast. One question we get is why a panel gets wavy, why you'll see have highs and lows. What that is basically, in an ideal world, and really, really high-end welders, I've seen guys that are doing this, they would actually weld this whole panel one shot. Boom, weld the whole thing. The reason that you see the waviness is because it's inconsistent heat between each weld. So unless you're a robot or dang near a robot, it's very difficult to get this weld exactly the same heat as this weld. You know, you might have a time where you dab a little slower than another time. That's going to be more heat here than there, which is going to cause more shrinkage. That's your highs and lows. You know, it's going to get more hot in one area and shrink more than another area. So you have to hammer it out to get it all flat, which requires hammering in some areas more than another. Perfect world, if you're a really good welder, you could sit here and go all the way across real fast, keep the heat exactly the same across the panel. It's going to shrink almost the same across the whole panel, so that when you planish it out or hammer it out, it's going to flatten out pretty much the same. So that's really, really difficult. I can't do it, that's for sure. But it is possible, but that's what causes the highs and lows when you see that in the panel. It's where you got too hot in one area versus another, not too hot, but hotter in one area than another. So that's what it is. If you hammer the welds out with TIG welding, you can get it flattened out, get it a lot closer than you can potentially with MIG welding, because MIG welding, the weld is more brittle, it's much more hard, so you can't really hammer and planish the weld out the same. So that's the sheet metal steel side of it that I wanted to show you guys. We're going to get into some aluminum now, so I'm going to set this piece here aside. So aluminum welding is a whole nother beast. There's a lot more that you get into with doing aluminum welding. First thing, obviously, is you're going to want to switch your machine over to the AC side. You weld aluminum on the AC side. You're doing most metals you're going to be welding on the DC side, but when you get into aluminum, some other metals, you are going to get into the AC, but pretty much aluminum is where you're only going to be using the AC for most DIY guys or gals. So aluminum is a lot more susceptible to getting dirt in the piece that can cause contaminants, and it can be more finicky, and a lot of people have problems with it when they're first learning because of that. It does weld a little differently. You have to act a little different when you're welding it. But once you figure out, there's a couple key things that people do, and once you learn to curve those bad habits, you can really you can make some nice welds with aluminum. So obviously with aluminum, you're going to have aluminum filler rod. The most common filler rod, and probably the best all-around filler rod, is like what we sell. It's the 4043 filler rod. This is going to probably be the best all-around, but when you get into some more different types of welding, like say a utility trailer or something like that, you may use a 5000 series because you want something that's a little harder. It's going to be a little harder than the 4043, but again, for most fabrication, when you're doing automotive stuff, especially for in the DIY world, the 4043 is going to get you by no problem at all. So that's the filler rod. Cleaning it is a big thing. You want to get the panels sanded like we talked about earlier, wire brushed, Scotch-Brite, however you want to do it. You definitely want to get the panel as clean as possible. If it's an old piece, an old casting, if you're trying to weld up a used original part, that's going to be infused with tons of oil and grease and grime and years of just soaking it up, especially cast parts. So you're going to need to work pretty hard to get that clean enough. So if it's something that's cracked or damaged, like this wheel here that I did started doing a little repair on. This is an aluminum wheel that was cracked, or I'm sorry, curved. Had a big curved area, it's dipped down in here. So what you need to do is you need to build that area back up. Now you can't just go and start welding right on that area that's been curved. You know, it's been dragged against the side of a curb, because there's dirt in there, there's grime in there, and just from using the wheel in general, it's just got all kinds of dirt into it. So what you need to do is you actually need to sand down below the surface. So this damage wasn't quite as deep, but I had to sand down below the deepest cut or damage in it to get down the clean, fresh aluminum before I started welding. Another thing you could do on cast aluminum or any cast parts is you can preheat. You can pre-bake the part. What that'll do is it'll bake out bake out any oils or grease, because when you're welding, you're doing the same thing. So if you heat the part up and it starts to bake out any kind of impurities, it's going to go right into your weld. So it's better to do it before you start welding and then clean the part and then start welding. On this part here, for instance, I did want to show, I'll see if Joe can get it here. On the back side there, you can see where it's black here, right down in there. That's basically where I didn't clean it on the back side, right in here. I didn't quite start sanding in there, so those impurities started popping out. And that's what you see when you start welding aluminum. You start seeing that black soot around it. You start seeing like salt, pepper kind of in your welds. That means you didn't clean it well enough. You probably got a dirty metal where you contaminated your tungsten, and that's what's causing that issue there. So that's a common thing that you can do. It's pretty good when you can start putting your aluminum welding to use, fixing a wheel, doing that kind of stuff, because it's really helpful. It might have been a wheel that you were going to throw in the trash. Now you can fix that wheel and put it back into use. So now that we kind of got into the basics of that, one thing that people oftentimes, we'll move this to the side here. Actually, let's put this on the ground just so we're not knocking it off the table. So one mistake or people get confused when they first start welding aluminum is clearance effect. You call a lot of different things, but on our machine here, we call it clearance effect. Basically what this is doing, it's really only used with the AC side of welding. What you're doing is you're affecting with the wave that's going, you're keeping it more towards the negative or the positive side. So to break it down, to make it as simple as possible for anybody that, to help you understand which way you need to go, the more negative you go on this dial here, it's going to penetrate deeper and it's going to have a smaller heat effective zone. It's going to heat up the panel less in that area. The downside is that the lower you go, the more negative you go, the less cleaning action that occurs. So when you're doing aluminum welding, when you first start welding, which we're going to show you in a little bit, you'll see there's a period of time where you sit there and you let the metal clean. The welder actually cleans the metal, and then you can start welding. So it's good because you can make a smaller weld. It's easier to control. It's not heating up. It's only heating up a small little area. Downside is that if your metal's not very clean, it's not going to clean and you're going to get contaminants in it. So you have to balance this clearance effect to just the right area for the piece of metal you're doing. So if you can test it on a sample spot, if it's something that's really crucial, or find a piece of metal that's exactly the same to test on it, that's really good. But if you're doing fresh aluminum, you can get down with an inverter machine pretty low on the negative side, so you can keep a real pinpoint arc and still clean. Another thing that really helps with clearance effect is a gas lens or having proper gas flow. So if you have a gas lens or proper gas flow, you can go more to the negative side because that's helping to shield and clean the metal more than if you had less gas. So it's going to use more gas, but you can get a more pinpoint weld, which is going to help. Now the other side, if you go more towards the positive side, that's going to clean more. It's going to heat up a bigger area, clean a bigger area, but that's good if you have a piece that's cast or is dirty. So for instance, when we were welding, and I have a little sample here that we can zoom in on this piece, these are kind of the settings, negative 3.5, and right here we have negative 1, negative 2, negative 4.5. It's pretty far down. Machine goes down to negative 5. And this is with a gas lens. You can see in this negative 4.5, you're starting to get that halo around it where that's contaminants coming up. That's not good. And where you're down in the negative 1, you can see this white area around it. That's the cleaning area. It's much larger than it is around this piece here. So that's how you can think about it, is that you're going to heat up a bigger part of the panel. It's going to be harder to control the puddle, but you're cleaning a bigger area. So you may have to crank the clearance effect to a more positive setting if you have a really dirty piece of aluminum. So I've dealt with like transmission cases, oil filter housings, things like that, that no matter how much you bake them, preheat them, whatever, it still wants to kind of pop out some contaminants for you. So if you play with your clearance effect, you can maybe you know, you can maybe get away with having you can still weld the metal pretty good, and you can get it to clean correctly. Whereas with this, you can crank it down and get a really fine, tight weld when you have it more negative to the negative side. That's the easiest way to describe it. You're really going to have to play with it to get used to it. But for a general setting, if you just want what do I set it to at least get me close? If you set it to, at least on our machine, if you set it to like to 2.5, 3, 3.5 range, that's pretty good. If you're welding without a gas lens, you may have to stick more towards the 3 or 2.5 range, or maybe 2. But I like to set it in the 3, 3.5 range because I'm using a gas lens. I have the gas cranked up pretty good, and that'll get you a pretty clean weld. So, oh, one thing I forgot. I wanted to show you guys what happens when you don't clean the metal enough. So this panel here, I didn't clean this at all. This is exactly how it came. You can see dirt. You can probably catch it on the camera there. There's dirt, there's grease down this corner here. So I tried to find a dirty area just to show you what it looks like. It gets worse than this if you're welding on something that's used. So you can see, I don't know, Joe, if you can get in tight on that, but there's little like pepper almost in that weld there. It's like little spots or specks. So what those are is that's the dirt floating to the top as you're welding. That's not good. I mean, it's welding, but you want it to be as clean as possible, so that's not good. You need to clean the metal. You need to have your clearance effect set correctly as well. That's going to help it clean correctly. So these ones up here, I didn't clean the metal, and I played with my clearance effect settings and my gas. And like this one up here, that's actually, you know, other than the little bit of halo around it, it's not too horrible. It's got a, it's okay. So for not cleaning the panel, it's okay. So that's one thing to look for. If you start seeing that, it's not good. You'll know it as soon as you're welding aluminum. As you're welding, you'll see black stuff just popping up into the weld. That's either should stop and clean it, or stop and clean it. That's really the only answer. So I'm going to hit this real quick again because this has been sitting. Aluminum or any metal, it starts corroding as soon as you're done. As soon as me stopping right then, it's corroding again. So at a microscopic level. So you want to clean the panel. Even if you cleaned it a day ago, you sanded it with the DA, it's good to hit it one more time to get it clean, wipe it with acetone, and then start welding. So this is a pretty clean piece, so I'm going to just go from there. So we're on the AC side. I'm down, like I said, around 3, 3.5 here because I'm using the gas lens. So as far as grinding, let me turn my pedal up now because we're welding a little thicker stuff here. So as far as the process of actually welding, and let me turn the machine off so I can show you kind of what your foot's doing here as well, so I'm not zapping myself. So, when you're welding aluminum, there's some machines out there that have a pulse effect on them, which is pretty nice. What that's doing is it's kind of pulsing. It's almost varying the amperage as it's going. You can do that yourself by pulsing the pedal. So as you're welding, because aluminum is like a big heat sink, it can get away from you really fast. So if you start welding here on one side, it's going to require more heat and more amperage to get a puddle started than when you got a lot of heat into the piece and you're all the way near the end of your weld. So what you need to do is you're always fighting that balance of it being too hot, too cold, too hot, too cold. So what you need to be doing is almost all the time when you're welding aluminum, my foot's going, you're playing with the pedal, you're going up and down, just getting, putting heat into the panel and then getting out, and heat into the panel. So what I like to do is I get a rhythm going, and that's what the pulse machines do, where they're pulsing at a certain rate. Get a beat going almost where you push the pedal down, you dip, you let off, not let off all the way, you just let off enough, a little bit, and then you push it down, dip. And you're basically, as we're dipping the rod, we're pushing the pedal in. So it's dip, 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 dip. So that's kind of what you're doing. If you can get into that beat, you'll get that nice looking weld, and you can kind of, you're basically putting heat into it when you're adding filler rod, and you're getting heat out of it, a little bit of heat out of it to keep the panel from just blowing through. So that's one thing that you want to be doing with the pedal. Another thing to mention, and we're going to show you, I'm going to try to do all these welds in one shot so he doesn't have to flip the lens up and down. Another thing you want to do when you're done welding an aluminum piece is you don't want to just be welding and let off the pedal. It's probably the worst thing you can do. What happens is if you look at the end of the weld, it's going to have like a crater in it, or cracks. It'll have a crater with little like real small cracks in it. That's a void. That's an area that's going to fail. Over time, it could fail. You don't want to do that. So what you want to do is when you're getting near the end of a weld or near the end of a joint that you're welding, if you're, say halfway down, you want to let off the pedal real slow and just kind of let the arc dance around and just slowly let the metal get to the point where it solidifies. You can even move your torch around a little bit to kind of just that last dab of material. You can put that last dab in and then just slowly start letting off your pedal. What that'll do is it'll let the metal slowly solidify, and it'll avoid having those craters or cracks in that last dab. That's very, very important. That's something that a lot of people forget. Get yourself in that habit when you're welding. So now that we're got this going, turn my pedal up. We're going to lay a few welds. I'm going to show you what you do. I'll talk you through it as we're doing the welds. And you can see how it's a little bit different than welding steel. So, all right, so we're gonna go. First thing you're probably going to notice is it sounds a lot different with AC welding. It's a lot louder. Let's see if I can get comfortable here. So we're going to go right across like that. And one thing you want to make sure is you're as close to 90 degrees as you can be, parallel to the table. And then you want a slight angle, just a slight 5 to 10, maybe 15 degree angle, somewhere in there. If you get too sharp of an angle like this, what's happening is you're shooting the arc off here, which is bouncing off, and it's hitting your filler rod that's waiting to dab in the puddle. And if you start welding aluminum and your filler rod's balling up on the end before you even go to dip it into the puddle, that means that your torch angle is too sharp. You're turned too far in. It's reflecting off the panel. It's putting more heat into the panel, and it's melting your rod before you even dip it in. So you want it, straight down and just turn just a tiny bit, and then move. So if you start seeing that as you're welding, like when I was doing that wheel I showed you earlier, I was kind of an odd angle, and as I'm moving around the wheel, I was getting turned, and my filler rod was doing that. So you have to, in your head, just readjust your arm or your hand and get it where you need to be, and then it helped. It's not as difficult on a flat piece like this, but when you get into actually welding parts or pieces where you're not bench welding like this, it's going to happen. So just keep that in mind. So I'm going to start the arc. You're going to see the arc actually bounce around, and you'll see it just kind of cleaning, turning white, and then you'll see it actually solidify and get shiny. That's when you add your filler rod. So he's going to flip it down. I'm going to start my arc, and then hopefully you guys can see what's happening there. So he's going to try and get in pretty close and do that. You ready? All right, so you can hear it's a lot different sounding. You can see I'm letting on the pedal so you guys can just see how it's just cleaning around the area. It's just getting a little clean. So I'm going to goose the pedal just a little bit, and then it's going to turn shiny. That's when you can add filler rod. Dab, dab. You don't dab until you see that piece get shiny again. You want to add to the front of the puddle. And as I'm dabbing,
I'm pushing that pedal down for, you know, each time. So I'm push the pedal down, let off. Push the pedal down, let off. Pedal down, let off. And then here, I'm going to slowly back off, move it around. And then there you go.
All right, so we'll let Joe kind of get in here and check that out. So you can see that cleaning area is pretty darn small. It's nice and tight. We weren't heating up a huge area around the bead. It was just right in that where the puddle was. So I'm going to turn the setting. I'm going to change it a little bit here. I'm going to turn the clearance effect up to like, let's say -1 or half. Quite a bit different. And I'm going to show you guys as I'm welding. Hopefully you can see how much larger of an area that it's affecting as I'm welding. And it's going to require me to put a little more, you know, put the pedal down a little further. You ready, Joe? All right, so start our arc. See how much bigger of an area it's hitting there? I'm going to go down, dab, dab. Just dabbing right to the front of the panel. Let me show you what happens when you turn your torch too much. See how it's blowing up my rod before I'm even dipping it? My torch was turned too much. Turn it more straight, and be back to where you need to be. And we're going to add one last dab, and then slowly back off. And then you keep your torch while that gas is flowing out. You want to keep your torch right over that last area just to help you know, keep it from getting any impurities as it's solidifying at the end. So if you look here in the center, that's that spot where I started turning my torch too far of an angle. See how much it changed the puddle? Got this big glob there. It was dropping the rod into the puddle before I wanted it to. That's definitely an issue. So we'll do another one here. I'm going to put it back down. We'll do another one. Hopefully you guys can kind of see what's going on. And we'll even show you a little bit of, you know, with a little bit of weaving when you move the puddle back and forth, what happens when you do that. You can, you know, play with the puddle a little bit. So let me know when you're ready, Joe, and I'll kind of... All right. So again, getting that area clean. Don't start dipping until you see it turn shiny. Shiny. And add some filler rod. So when you're doing the weaving, you're kind of letting off the pedal and goosing it when you want to put it in. You're moving up and down and moving forward. You're overlapping it. See, I'm moving the pedal back and forth. I'll put one right in the center and then back off. Let's solidify. Now, I'm not the best weaver in the world. I kind of just started getting the hang of it myself, but kind of see how it's overlapping the panel, or overlapping the welds are overlapping each other almost like snake scales, if you will. Now, why would you do that? Well, other than trying to look cool and getting on all the fancy weave hashtags on Instagram and on the internet, Why would you use that? Well, it's good actually if you're filling a joint that's either you needed to bevel real tight or you're trying to cover a wider area. So this piece here, I did a little, put two pieces together and did a little weld and weaved across. So what you may need to do, depending on the instance, is you do that first root pass where you just went straight across, and then maybe you needed to come across and bridge that piece a little more. That's when you could start weaving it across and dipping and adding. That's something that it takes time to get good to do that. I'm not really that great myself, but it's something that we seem to get a lot of questions about. People want to know how to do it. That's the basics to start doing it. You just move the torch back and forth, add each time as you're going forward, and you can get it from there. So that's those. Last couple of things I just wanted to talk about, especially with TIG welding, or a couple tips rather. Let me shut this off here. If you're welding to the end of a panel, and this is even on steel as well, or if you're doing something where it's an edge, if we were welding on the edge of this panel here, or you were doing, say, two pieces together and you're welding on the edge, or rather like this, and you had basically you're welding right near the edge. What's happening is your shielding gas, it's passing by the edge of the panel, and you're losing shielding gas, which can cause some contaminants to pop up. So one thing, it's a cool little trick, is you can put a backing plate, like a copper backing plate, on the edge there. So if you're welding, say it was just like this, and you wanted to get to the end here, your shielding gas can kind of stay on the back of this, on the backing pad. Same thing if there's some gap that you're welding. If you're trying to fill a gap, you can put something from behind that's going to help block the shielding gas to keep the metal clean. Another thing you can do is when you're welding a piece together and you want to try and get that end piece, you don't want to end right on the end of the piece, you can actually jump your arc over onto that backing plate there, and that'll help save that last little dab that you do there. You're not ending right on the end of your panel, you're kind of jumping the arc to your scrap piece that you got set into the side there. So that's a little tip that you can do that's pretty helpful. Another thing you can do is you can put a piece like that, or a big chunk of a big thick piece of metal, you can put underneath especially with aluminum, you can put underneath to be a heat sink, so it kind of sucks that heat and takes it down. That'll help save it from warping. There's even some of those like fire pit bricks you can get that are meant for soaking up heat. Put those underneath, and that really helps quite a bit as well. So a bunch of stuff you can do to try and keep the heat from going into the panel, or get it to spread out to other places so that it's not warping it quite as much or distorting it. So that was the basics into this and to getting your first couple of little aluminum welds started. If you have any other questions, feel free to send us an email, comment on the video, or comment on any of our other social media outlets, and we can do our best to get back to you. But that's just kind of jumping in the basics that you need to know to get a weld started, to get you going. There's more stuff than that, obviously. Send us an email, leave us a comment, let us know what you want to learn. We're happy to do short little videos that'll teach you on just those little things. You guys just got to let us know, and we'll try and scope in on just those things. So thanks for watching, and we'll catch you next time.